Alright, here is part 2 of Unit 3's test. If you want to retake it, you have to make corrections, and so this explains how to do those corrections, get the problems right, turn it in, and I'll grade it for a retake. Draw a graph of an odd function that has a negative lead coefficient. So this is pretty straightforward. We're going to draw an x and y axis. Remember that odd functions have this shape. The endpoints go in opposite directions. Now the one I just kind of sketched down there in brown, that has a positive leading coefficient because the right hand end goes to positive infinity. When you have a negative lead coefficient, it goes upside down. Okay, so those are odd functions. Endpoints go in the opposite directions. But the other thing is we want this odd, these are, I guess I should say, odd degrees. But we want an entirely odd function, which means it has to have symmetry about a 180-degree rotation. So you got to be a little bit careful when you draw this. The easiest one to draw would be one that went like this. You got to have a negative lead coefficient, so the right-hand side's got to start by going down. So if I rotated that 180 degrees, it would be a perfect match and lay on top of itself. Right-hand side goes down to negative infinity, so it's an odd function, negative lead coefficient. Another option would have been doing something like this. Maybe you wanted to put a hump in it, but you'd have to be very careful. And that one's pretty decent. If I were to rotate that 180 degrees, this hump up here would then be down here, and this hump down here would now be up here, and it just look exactly the same. Some things you could do if you're not a very good artist or drawer, you could make some marks, like saying this is at, I don't know, -3. This is at +3, because they'd have to have the exact same size peaks on them. You could say, hey, this is at -2 over here, and this is at +2, and that would make sure everything lined up perfectly when you did a rotation. Okay, so that's problem 13, and I judged that not harshly, but one of the key things is you need to make sure, and mine doesn't even do it quite right because I'm drawing with a iPad here, it should go right through the origin. Not all of them have to go through the origin, but that would be the easiest way to make sure it rotates about the origin and you still get the same graph. Okay, next problem 14. A polynomial that is degree n will have n solutions. And that's if we're counting multiplicities. So, for example, if it's n squared, you will have 2 solutions, or x squared, whatever it is, whatever the degree is, x to the n. But if it was a squared quadratic, you'll have 2 solutions, although you could have less than that if you don't count multiplicity, so you might have 1 solution, but that would have multiplicity of 2. So what I was looking for, there was n solutions, exactly the same degree, although you could have less than that if you don't count multiplicities. Find the zeros of this polynomial. Remember, to find zeros, you set the function equal to 0, and you factor it. So I'm going to do some factoring here. I got x there. So this first trinomial is x and x, 2 times 4, negative, negative. The second quadratic binomial, I can take a 4 out, leaving me with x squared minus 2. And then I've got that x on the end. And we want to find out what makes those 0. So I said each factor equal to 0, and I solve them. So there's 2 solutions. The number 4 doesn't give me any solutions. It doesn't have an x. X squared minus 2 doesn't factor, but I can take the 2 over and square root both sides. So there's 2 more solutions. And then the last factor, x, there's only one thing that makes it 0, 0. So 1, 2, 3, 4, 5 solutions. If you look at the degree of this, I got an x squared, that's x to the 4th. x to the 5th. So I should have 5 solutions when I get done, which I have. Problem number 16. Find the zeros of this. You certainly could graph this thing, and maybe it would tell you the solutions right away using your calculator. I'm going to see if I can factor it. So I'm going to group the first 2 terms together, put a plus sign, and then group the last 2 terms together. I'm only doing this because, hey, if I got 4 terms, there's a good probability that I can factor by grouping. I'll pull a negative 16 out. And you'll notice now I have a common factor, x minus 3, in each of these, separated by a minus sign, so they're separate terms. Pull out the x minus 3, and I'm left with the x squared in the first term, and the minus 16 in the second. Continuing to factor, that's a difference of squares. And now I can identify my zeros. 3, 4, negative 4. Again, your calculator, if you graph that, that's where it crossed the x-axis, those 3 x values. And problem 17, we had to simplify. I think I'd get rid of this 3 here first because I got to deal with that innermost set of parentheses. So I cubed the 4. I use the power to power rule to multiply these exponents. Same thing with the f to the negative 4. On the bottom, I'll take care of the squaring of everything. All to the negative 2 power. Now before I raise it to the negative 2 and flip the whole thing over, what I'm going to do is simplify inside here. So 64 over 36, both divisible by 4. 16 over 9. E9 over E4, that gives me e to the 5th on top. And that negative 12 means 12 on the bottom. So that's f to the 20th, because I already got 8 down there. Okay, notice it's still to a negative 2 exponent because I didn't change anything or move anything because of that negative on the outside. Now I flip the whole thing over to deal with the negative exponent. Now it becomes a positive 2, and now I square everything using multiplication. 16 squared, 256 maybe, I'm hoping, e to the 10th. And I've got it simplified. I can't cancel any of the f's with the e's, or 81, a bunch of 3's, and 256, a bunch of 2's. So I think that's the correct answer. You may want to check what 16 squared is. And finally, problem number, on problem 18, identify the real zeros of the function. So there's a real 0, there's a 0, and there's a 0. Label relative mins and maxes. This low point down here, relative min. This low point is a relative min. Lowest points in that region. That point right there is a relative max. That's A. Just point to them and say what they are. These are the zeros. X doesn't equal 0 there, but the Y value equals 0. Part B, name the zeros. So I can see negative 1, negative 2, negative 3. So these zeros occur at negative 1. This 0 occurs at negative, or positive 1. And right here, I get 0, the multiplicity of 2, because the X value is 0 right there. So I've got 4 zeros for this. It's a 4th degree polynomial if you look up here at the top. So we needed 4 solutions. We found them all, which helps us out. With part C, how many imaginary zeros are there? There's none. I already found 4 zeros. It has 4 solutions, so it can't have any imaginary. And then I have to write, determine the polynomial. Well, if I know what my zeros are, then the factors are x minus that 0. X minus 1 gives me a 0 of negative 1. Or x plus 1 does. X minus 1 gives me the positive 1. X squared gives me 0, multiplicity of 2. I just had to multiply these together to get it in standard form. the first two binomials, that comes from a difference of squares, x squared minus 1. I distribute the x squared, and that is the polynomial, let's call it p of x, that would have all of these solutions. And that's how you do test part